More in depth on the graphing techniques of a quadratic here in vertex form. Okay, so if A is greater than 1, or sorry, the absolute value of A is greater than 1, that means that it is going to be narrower, or it's going to have a vertical stretch. Okay, if A is absolute value of A is between 0 and 1, that means it's a fraction, right? 1/3, 3/4, stuff like that. Then it will be wider, and these are being compared to the parent function y equals x squared, right? Where you have 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. So if it's a fraction in front right here as your a, that means that you're going to have it's going to be wider than the parent function, and it's going to have a vertical shrinking going on. Okay, if a is positive, that means your graph is going to face up. If a is negative, then it faces down. Okay, so those are the things with A. Now H, it always moves left to right. H moves left to right, but it's always the opposite, right? So A moves opposite left to right, and then K stays the same, and it just moves up or down. And then the last thing is the vertex, right? That's why it's vertex form. Your vertex is H comma K. And your axis of symmetry, the line that kind of divides your parabola in half, it's called the axis of symmetry. It is always a vertical line. And in the book on your assignments, it will just say ask for just the axis. Okay? And that is x equals h. It is a vertical line, so you have to have the x equals part. It is a vertical line. A couple more things. Once you have the vertex, all you need really is one other point, and then you just fold the graph over this axis of symmetry. So all you need is 2 points, the vertex and another point. Well, you can find another point by having, it would be the x-intercept, where the graph crosses the x-axis. And to find that x-intercept, what you would have to do is you would have to plug in 0 for y. And solve for x. Solve for x. So that would be, this would be a lot more complicated, and it would give you a point, some number, right, for x and 0y, and you could put that on your x-axis. But that's more complicated. The easier one is the y-intercept. And even some points, especially in vertex form, in standard form, finding the y-intercept is really easy because you just plug in 0 for x and solve for y, and it's really easy in standard form because you have x's in 2-year terms out of 3, and so it's automatically going to be 0. So in standard form, it's really easy. In standard form, it's always 0 for x, and then it'd just be your c in standard form. And slope intercept, it's a little more complicated. That is just going to be, you're going to plug in 0 for x. It's a little more complicated, but not too bad. And then you just find your answer for y. But once you have one of those points, then you can just fold it over that axis of symmetry, and then you have your graph, and you can draw your u. So let's go ahead and do a couple examples of graphing, just graphing in general. The first one here, f of x equals x squared minus 4x minus 2. We're just going to do it by plotting points. So it's a quadratic, so if we start at 0, I'm just going to plot some points here. I want to plug in 0 and see what I get for y. Like I said, that's pretty easy, right? Negative 2, because we get 0, 0, negative 2. plug in 1, all I have to do is look at the coefficients. 1 minus 4 minus 2, that's minus 5. And then plugging in 2, see what I get more complicated, I got to square it, right? So I get 4, I get negative 8 and negative 2, so that's negative 6. Okay, and then I can plug in 3, so I get 9 minus 12 minus 2, that's another negative 5. So look, because these two have the same y value, look at their distance between that middle number here, that 2, negative 6, that point 2, negative 6, they're both 1 away. That means that 2, negative 6 would be the vertex, because it's in the middle of the two values that share that same y value. So you can graph this. So I can go 0, negative 2. I can go 1, negative 5. I can go 2, negative 6. 3, negative 5, back up to negative 5, and there I have my graph. So there's my graph on that one. So I can always just plot points. I can always just plug in x's and find out what the y's are and graph those points. But with quadratics, it's a lot difficult rather than with lines, because all we need is 2 points. With quadratics, we need at least 2, and one of them has to be the vertex. Okay, this one, we can graph this one, g of x, negative 1/2 x squared. We can compare that to y equals x squared, the parent function, which is 0, 0, 1, 1, negative 1, 1, and 2, 4, negative 2, 4. So there's our parent function, right? Y equals x squared. Now this one, like we said before, it's a negative, so that means it's going to face down. So it would face down here like this. 4. So it would face down. That didn't go through the points, but that's okay. And now that 1/2 is a fraction, right? So that means it's going to be wider than this one. So our ending one is going to be wider by a factor of 2, right? So normally it's we plug in 1, we get 1. We plug in negative 1, we get 1. We plug in 2, we get 4. But now we're going to multiply these by 1/2, right? Our x squareds we're going to multiply by 1/2, or negative 1/2. And so here we're going to get negative 1/2, and here we're going to get negative 2, right? So we're going to go 1/2, and then negative 2. So you can see that my graph's a little bit off. But this side you can see is wider. The green one there I didn't really graph very well, but on the right side there, but it is wider because it is a fraction. So that would be my end. The purple one would be my graph of that. Okay, here's a couple more. These are in vertex form, right? Those were those graphing techniques. So we look, we find our vertex first. Opposite of the inside, negative 3, outside stays the same. So we go ahead and graph that. Negative 3, 1, 2, 3, down 4. Graph that point, negative 3, negative 4. It's going to face up because we have a positive in front, right? There's no negative in front of that parenthesis. So it's going to face up, and now we just need to find another point. I can plug in any number for x, any number you want to. Just plug a number in for x. I usually do 1 to the right, so a negative 2, or 1 to the left. Oh, that's 3. 1 to the left, which would be negative 4. So any one of those is going to give me a small answer, right? I don't want to plug in 2 or 7 or something like that, because I might have some number going way up here that I don't want to graph because it's too big. So these numbers close to this x value of negative 3, which is called our axis of symmetry, right? X equals h is the axis of symmetry, so our axis of symmetry, or just axis, is x equals negative 3. So it would be this line right here that goes through that vertical line. So now I can plug in negative 2. Negative 2 plus 3 would be negative 1. Negative 1 squared is 1, and 1 minus 4 is negative 3. So negative 3. And you can see if I plug in negative 4, the same thing is going to happen. I get negative 1 squared is 1, and then I subtract 4, which is again negative 3. So you notice that those have the same y value because they're both 1 away from that axis of symmetry there. So they have the same height. So now I can draw my graph, draw my u. There it is, all done. Okay, here's another one you can practice. You can pause the video and practice this if you want to. I'm going to start going already. I want to graph my vertex. So when you get good at these, you basically can just go without even writing down the vertex or whatever it is, right? 2, 1. then you can start. I know it's going to face down because it's a negative, and it's going to be narrower than our normal one because it's a -3 out front, and then I can just plug in a point. I just want to do 1 to the left, so that's plugging in 1. So 1 minus 2 is -1. -1 squared is 1, times it by -3. Right? And then I'm going to add 1 at the end. So -3 plus 1 is a -2. So I plugged in 1, I got -2. So I go 1, I got -2. And now, here's my axis symmetry, right? X equals 2. So it's 1 away this way, so I go 1 on the other side, and it's going to be the same height. And then I can draw. See how it's kind of narrower? It's not the best drawing. Okay, so here's your homework for those two problems, 9 and 11. So you could use those examples for before to start practice on number 9 and 11. And then here in a second I'll start actually doing problems 9 and 11, so you can start watching these. If you get stuck, you can watch the video, and if you figure it out, go ahead and pause it and finish your work, and then come back and finish the video and see if you got it right. Okay, so here it is. Here's the problem, right? We're asked to graph these. So we know what this looks like, 0, 0, 1, 1. And we're actually asked to graph on the same one. So there's the parent function. This one, I'm just taking my x squared, which is all these y values here, and then timesing them by 3, right? So I'm going to times them. Let's just do this one in red. So I'm going to times that by 3. So 1 times 3 would be 3. 1 times 3 is 3. 4 times 3 would be 12. So there's 12 way up there. And then I would graph this the best I could, making a U. And so let's see how it's narrower by a factor of 3. So there you go. There is B. We'll go ahead and do C, and here I'm actually dividing by 3, right? Timesing by 1/3 is like dividing by 3. So I'm going to take 1 and divide that by 3. So that's 1/3. So I'm going to estimate, right, somewhere down here. Same with this one, somewhere down here. And then 4 divided by 3 is 1 1/3. So I go 1 1/3. Best guess estimate here, and so you can see that this one is definitely going to continue to go wider than that one. So there is number 9, all on the same graph. So I guess D, we kind of already said this, but D, how does the coefficient 3 and -1/3 affect the graph, right? Well, this makes it narrower. This makes it wider, right? A fraction makes it wider, and a whole number makes it narrower. Okay, so here is number 11. So we're asked to graph these again on the same graph to see how they can kind of compare, to y equals x squared. So we can start graphing these. Here I'll do A in green, right? -2. So that means we're at x minus 2, so it means we're going to actually move right 2. And then it stays at 1, 1, 2, 4, 1, 2, 3, 4, and 2, 4. So see how it just shifted that parent function right 4. So that's how this one differs, right? Here, I guess what you're supposed to probably do is actually just plug in numbers from these and make tables for each of these and then see how the graph differs. But we can just know that the vertex of this, like B, is -1, 0, right? So I'll do this one in B, or blue, B. So that one's going to move left 1. There's my vertex. Up 1 over 1, up 1 over 1, and then 2, 4. 2, 4. So you can see how it moved from the parent function. Right, my parent function's right here. There's my parent function. So we're seeing how these move from the parent function. D we'll do in purple. So +3, so that means going to move left 3. So 1, 2, 3, and then up 1 over 1, up 1 over 1, 2, 4, 2 from the vertex over 2, up 4. Or I could plug in numbers and use the axis symmetry. So we see that when it's a negative, it actually moves right. When it's a positive, it moves left. So that'd be your answer to D. Okay, so there's your homework problem. So you can use that and start doing them. You can check your work at any time. Okay.